Good evening. So before we begin what we have planned for today, let's do recapitulation, because it's very important that we keep reminding what we had learned in the previous classes. Just let me activate my pen. Yeah. So if you recall, in the previous lecture, we had studied different types of sensors. So the first sensor was the electrical strain gauge, ESG in short, and the other was the vibrating wire strain gauge. Alright, so do you recall the principle of the electrical strain gauge? Now, why I have written these down, both are basically static. They are used for static measurements, static strains. So what is the principle of the electrical strain gauge? Principle is very simple. What we deal with is a conductor, foils like this, which are bonded on the component, and what we measure is we measure the resistance across the conductor. So this is a special alloy. So if the component is under any kind of stress, so what will happen? The resistance of the coil will change, the foil, sorry, and this is represented by the relation delta R by R is equal to the gauge factor multiplied by the strain we have to measure. We can use the symbol S1 or you can use the symbol epsilon, does not matter. So in the laboratory, if you recall, we had done the measurement, and you recall the value I had informed you in the lab of the gauge factor. In the lab, we had recorded the measurement of the resistance. So do you recall the value of the gauge factor which I had told? So let me just repeat. It was 2.16 was the gauge factor.
Yes, sir.
All right. And what's the principle of the vibrating wire strain gauge? It's basically based on the vibrations of a pre-tensioned wire. So basically here there is a pre-tensioned wire which is connected to the monitor structure and inside a capsule. So this wire is pre-tensioned, and what we measure is the frequency of vibrations, and this is given by the simple law of physics 1 by 2L under root T by M. So what is T? T is the tension, M is the mass per unit length. So what we can do is we can do the conversion of this formula, and of course L also comes into picture. So if you recall, the value of L I have yet to tell you. So this L is basically 10 centimeters. The value of L that day was omitted, so this is 10 centimeters. And then you can again rework on the formula. All you have to do is just replace M by the product of the density and the cross section area, and the tension, this can be replaced by the strain multiplied by the Young's modulus. This is stress, and then area. So with this you can derive an expression for the strain in terms of the frequency. So you will find that the strain is given by some factor multiplied by square of the frequency. And what is that factor? So if we can derive it, so 4 will come in the numerator, then L square, and then what will come in the numerator? A is cancelling out, and then we have rho will also come in the numerator, and then A has already cancelled out, so the Young's modulus comes in the denominator. Alright, any other thing we have missed out? Yeah, then this has to be multiplied by f square. So is this correct? Just please cross verify that we have derived the correct formula. So in the experiment which we had done in the laboratory, our staff, Mr. Himanshu, he stood over the beam and he produced compression effect, if you recall correctly. So we had measured the two frequencies, f1 and f2. So basically, what is the strain here? The strain induced will be equal to the difference, the differential strain when the person is standing, that will be equal to the difference of the frequencies, 4L square rho, then Young's modulus in the denominator, and here we have f2 square minus f1 square. So by this, if it's a tensile strain, it will come out to be positive, and if it's a compressive strain, it will come out to be negative. Alright, so any doubt you have in this matter with regard to the electrical strain gauge and the vibrating wire strain gauge? If you have any doubt, please inform. Raise hand if you have anything, then we go further. So no doubt.
So what is the value of R? We know delta R. R is for electrical strain gauge.
Value of the R was noted by you. If you recall, there was an initial value. See, ideal value is 120 ohms, but if you recall, the value which we noted was up to 3 decimal places, total of 6 significant figures. So our value was something around 120 point something, I don't recall. But if you see the video, the video has been uploaded and you will be able to find what's the exact value. So this is basically 120 is we say the standard value, but the actual will be something, decimal places will also come. So that is the initial value R0, and what happens if you subject it to tension, the value will increase. If you subject the specimen to compression, the value will go down. Alright, so this value,
sir, actually,
yes, please go ahead.
Yes.
Aniket, you were saying something, the actual.
no, sir, actually, I want to say that in denominator R is equal to R is the original value.
Yes.
Delta R by R,
Yeah.
R is the original value.
We can use a subscript 0. We can, what we can do is the
okay.
R0 we can use the original value. This is the original value. Alright. So this clarifies. So now you have everything for the two sensors. And then let's go to the dynamic side. So we had two sensors which we had studied for the dynamic measurements. One was the accelerometer, and the other was the piezo sensors. So piezo is a general term. And what is PZT? PZT is a special commercial name. There are over 200 types of piezos and PZT is one of them. So do you recall what does PZT stand for? Lead zirconate titanate. P is taken from lead and ZNT from zirconate titanate. So accelerometers, basically for the accelerometer which we had used, the manufacturer gives us the conversion factor 100 millivolts per G. That is the conversion factor given by the manufacturer, PCB. PCB is the manufacturer, they have provided in their data sheet. This is the calibration constant of the accelerometers. So in the output you will get for accelerometer you will get a profile. We'll discuss that, but what you get is the voltage response. So any voltage you have to convert into acceleration by this conversion factor. Alright, so that means that if the acceleration is 9.8 meter per second square, so this will generate 0.1 volts. Alright, so in general, if you want to derive the acceleration conversion constant, so it is 98 meter per second square per volts. So all you have to do is just multiply by this factor the voltage plot. If you are using Excel, just apply this constant multiplier and you will get everything in the acceleration terms. Alright, and let's now come to the piezos. So for piezos I need to make another sheet like this, so just hold on. I can just erase this out. Let me erase this out. So for piezo sensors we had basically seen two effects. One is the direct effect and the other is the converse effect. So what is the direct effect? Direct effect is the sensor effect. And what's the converse effect? It's the actuator effect. So sensor effect is that we had cantilever beams, and what we had done, we had given them excitation. So piezo was bonded at the root and it was connected to oscilloscope, and when we were hitting here with a pen, we were seeing the response like this, that is damped free oscillations. So basically this is the sensor effect, that when the strain is happening here at the location of the piezo patch, what happens is that this is converted into voltage response. So what is the relationship between the two? So in general we have the two equations. So let's just recapitulate the equations. So starting with the converse effect equation. So in general, piezo patch, they behave like any other elastic material. If we apply stress, we get strain, which is proportional. So let me just ask you, what does this bar indicate? Bar indicate that this Young's modulus is
dynamic Young modulus.
Yeah.
Dynamic Young modulus.
It's dynamic Young's modulus. And what does E indicate here? E indicates that this has been measured under zero electric field, means the measurement done is under zero electric field. And how do we ensure zero electric field? We do short circuiting. We do short circuiting of the top and the bottom electrodes, and this ensures that there is no net electric field. So this is one part, and the other part is that strain is produced not just by stress but is also produced by the application of electric field. So this is the equation for the converse effect. That is, we apply electric field, we see the development of strain. And then there is equation for the direct effect also. So first of all, they behave just like parallel plate capacitors. So we apply an electric field, we see the development of charges. So this equation, how do we get this equation? This is basically the representation of the equation for parallel plate capacitors. In physics you have learned Q equal to CV. Do you recall the equation Q equal to CV? So all you have to do is just this Q is the total charge, whereas here D3 is the charge density. What do you mean by charge density? Charge density means it's basically Q divided by the area, the surface area. Okay. So with this you can derive from Q equal to CV, you can derive this equation. And how is this electric field related to the voltage? Basically electric field is related to voltage, that it's basically V by H. So this is how the two are related. So this is one part, and then there is the other part. The other part is that charge is produced not just by the application of electric field but also by stress. So D31 comes again here into the stress. So now you see here in both the equations we have D31 coming into picture. So in one case D31 is connecting electric field with strain, and in the other case it's connecting charge density with the stress. So if we are using it as a pure sensor, then we will not have this term. So this term goes because there is no external electric field, we don't apply any external electric field. So we get a simplified equation for that case, D3 equal to D31 into T1, and you can elaborate this equation further. So let's do that. I give you homework, so some of you may have tried, but let's do it here. Let me just erase this board. So is my writing clear and is coming real time? I hope there is no lag.
Yes, sir. Yes, sir.
Okay, fantastic.
No lag, sir.
No, sir.
Alright, so we start with this equation. Yeah, so charge D3 is equal to epsilon 33 E3 plus D31 into T1. Alright, and this term is 0 because there is no external electric field. So by mistake I had made the other term 0. So we have this, and then we multiply both sides by the area A. So what we get, this is now Q, the total charge, and on the right hand side we have D31, and this stress we can break it down into strain by bringing the Young's modulus into picture. Alright, and then we have the area A, and this charge, total charge, can be written as C into V. And what is the capacitance? Capacitance is given by epsilon into area divided by the H, the thickness. So this here now D31 into S1 into Y11E and area. So what will happen? Area will get crossed out. So let me just change the color of the pen. So the area is getting crossed out, both sides cancelled out. So we can derive the expression that the voltage, the strain, okay, voltage is here this side, C into V, so we have to multiply by V also on this side. So the strain S1 is then finally given by this expression that we have on the top, or we can use the voltage on the left hand side, that's better. So voltage, let me just erase this out to have something simple. So we have the voltage, and on the left hand side, and on the right hand side we have D31, then the Young's modulus, and then on the exterior we have S1, the strain to be measured, and in the denominator, what we have in the denominator, we have epsilon 33, and this H also goes in the numerator, so we have H. So is this now correct? Please you also verify that this derivation is correct, and let me write it clearly on the top because my pen is doing a little bit slip. So let me write once again clearly. So this is the main equation we use for obtaining the strain. So so we have here voltage as a conversion factor for strain. So here we have D31 multiplied by Y, and of course we have a bar at the top, then H, then we have epsilon 33, and then we have here S1. So I have given you a job that you go to the website of PI Ceramic. We have used the piezo of this particular grade, PI Ceramic. So all you have to go is just go to the website of PI Ceramic and you work out these conversion factor. Let's call it as K. This whole thing we can call as K. So based on the metal type PIC 151, the grade we have used in our lab is PIC 151. So for that you work out the exact value of K. I have given you that if you round off, the value comes out to be 200 millivolts per strain, per microstrain, sorry. The constant comes out to be 200 millivolts per microstrain. If the strain is 1 microstrain, that is 10 power minus 6, this will generate 0.2 volts. Alright, so you have to calculate the exact value. So find out these parameters, values of these parameters from the site of PI Ceramic, and then you can calculate the exact conversion factor K. So what you are getting from the experiment is the voltage output like this. You will see plots like this. The way Madhu has done the experiments, you will see plots like this. So all you have to do is you find out what is the voltage, and from the voltage, just like we have used the conversion factor for the case of the accelerometer, so use similar this conversion factor to obtain the actual strain. Alright, so any doubt till now? So if no doubt, then let's
Sir, all the parameters like like dynamic young modulus, electrical permittivity, all we get from PIC 151.
yes, of course, you get everything from the PIC 151.
Okay, sir.
So here for this case, dynamic and static Young's modulus will not make much difference. So you can use the static value itself, you can use. So they won't make much difference here. So conversion factor, the static values you can use. And the thickness, let me tell you, the thickness is 0.3 mm. 0.3 mm is the thickness of the piezo patch. So if no doubt, then Madhu, are you ready? You have the data with you. Let me unshare the screen and let me make Madhu as the presenter, so that we tell exactly what you all have to do. Let me just, okay, I think organizer is Major Anu, so you can make Madhu as the presenter and she can share the screen, and then we decide. We have to distribute everything among you all. So I have a formula, simple formula, how we can distribute so that everyone gets some random work.
Hello.
Okay, what is this plot? This is for the piezo or accelerometer.
So, accelerometer, sir.
Okay, so can you just choose the columns D and E so that we just see a plot quickly? Just choose the entire columns and then go to the plot and let's see the response. So all this data you have shared in the
Teams.
teams you have shared. Very good.
Teams file.
So everyone has access to this data. So and she has shared multiple files. So let me tell you how do we use the multiple files. Now for example, here you see here there are peaks. This is one peak, second peak, third peak, fourth peak, fifth peak. 5 peaks you are seeing, right? So file number 1, it has peaks from 1 to 5. File number 2 may have peaks from 6 to 10, or maybe 1 or 2 peaks more or less. So that's how we have to count the peaks. So I again forget, Madhu, this is for the piezos, right? Sorry, this is for accelerometer.
Oh, this is for piezo. I'll do it for. This is for piezo actually.
Okay,
File
fine.
6.
So that's how you have to make use of. She has already specified that this is for piezo. So similarly, she will specify the file for accelerometer. So your job is that you make use of your 4 digits of entry number. Okay, 4 digits of entry number, add them all. Your own entry number you have to add.
To column E.
No need, just keep this. I am now giving a simple formula to distribute these among yourselves. So for distribution, all you have to do is that you make use of 4 digits of your entry number. Okay, then you add them. All the 4 digits you add them. And let's say the sum comes out to be, just a hypothetical case, let's say the entry number is 9999. So the sum will come out to be 36. 2 digit number, then again make it a 1 digit number, it will come out to be 9. So now your job is to look at the 9th peak. So find out the peak value of the voltage in the 9th peak. So 9th peak, how do we define? This first file has peaks from 1 to 5, so the next file will have the 9th peak. Okay, so that's how randomly you have to choose the peak and just find out what is the voltage at that particular peak. Then you convert that voltage into strain. So that's how you get the value of the strain measured by the dynamic strain measured by the piezo. Similarly, for accelerometer also, you according to your own entry number, use the particular peak and you will be able to get it. In case you find that your entry number is 9, I mean your addition is coming out to be 9 and you have only 4 peaks, then what you do, you divide it by 2. Okay, so you have to get some randomly. I am distributing this. One way is that I say, okay, person number X, he has to choose this peak, this file. Rather than that, I have made it simplified that you use according to your entry number. So that's how all data gets distributed to everyone, and according to your entry number for last 4 digits, you choose the particular peak and find out what is the peak acceleration, and similarly from the piezo find out what is the peak strain. Okay, and the values for the ESG and the vibrating wire strain gauge, the frequencies, basically they are, everyone must have noted at that time, so use those values. Now this could be the last digit might fluctuate, the third after third decimal place, because the beam was under bending, so there may be fluctuation, but you use your own value. So we are not checking what value you one is producing, but we are just checking that you are able to convert that into physical values of strain. So basically for the experiment 1 which we have done, so all you have to do is just write an abstract, nothing else. So abstract, what should be abstract having? Abstract should have objective, then your methodology and results, and conclusions. So this is what we expect, and everything should be written in past tense. Okay, past tense, third person, and tomorrow I will make the provision in the Moodle so that you can upload your files in the Moodle. Okay, so that's how we will go. So if you have any doubt regarding experiment number 1 which we have done, that is lab number 2, experiment number 1, if you have any doubt, anything, you let me know.
Sir, entry number related is not clear to me.
Okay, I will take your example. Tell me.
For any random.
Tell me your entry number. Last 4 digits of your entry number.
2161.
Sorry?
2161.
2161. So what is this?
2161.
2161. Yes, I am saying same thing. So the sum is how much? 4 plus 6, 10. And you convert it into single digit numbers of first peak. You have to look at the first peak. Any other example? Okay, Major Anuj, what's your entry number?
It's 2813.
2813. So what does your sum come out to be?
14.
14, and you again sum, so it comes 5. So fifth peak.
5.
Okay. So most of the cases it will work if, for example, you find that it's exceeding in some particular case, you divide by 2. So data is already shared by Madhu.
Sir, mine is 9. Sir.
Yes.
Sir,
if there is any contradiction,
mine is coming 9.
9, so 9 peak. If 9 peak will definitely be there. So but peaks, how you have to count? He has multiple files for the piezo accelerometer. So you have to count first file, you have to count in that sequence, then second file, it becomes the higher. So the idea is that everyone should go through the data.
Excuse me, sir. So we have already taken 30 peaks for both accelerometer and piezo.
30 peaks more than enough. Do you want to say that we can extend even the 2-digit numbers?
Yes, sir.
Okay, I think if your yes, then we have, if we have 30 peaks, then we can make use of the 2-digit numbers also. If we should not just rely on single digit number, we can make use of double-digit number. So use double-digit numbers, and in worst case, if for example someone has 999936, then that case you divide by 2. Okay, but that case is a hypothetical case. So now it's clear. We will not convert into single digit number, we will convert into a double digit number. But if your addition is coming single digit number, then use that. But we will not convert double digit number into single digit number. Is it clear now?
Yes, sir. Sir, report is in handwritten or type in Microsoft Word and any other?
Yes, it should be typed, and the format we follow same for CVL 861. So you can go to the website of 861 course and just see the template. So here I am not asking you full report, I am just asking you abstract. You don't need to show how you have done the calculations. All the calculations etc. you do in your own way. You don't have to type that this formula I have used, this is the initial value, this is the final value. Don't have to disclose this. So basically work on your own. You don't have to disclose that your entry number was coming out to this, so I have chosen this particular peak, this particular, no, just give us the final value, what according to your assigned peak, what strain you are reporting for the piezo, what strain you are reporting for the, what acceleration you are reporting for the accelerometer, what strain you are reporting for ESG and vibrating wire strain gauge. Okay, use your own values. So any doubt on this? So don't have to
one single report like for this
only abstract. So abstract should not be more than 250 words. Standard is in abstract is 250 words maximum.
Okay, sir.
So not more than one or three quarter of A4 size sheet. Abstract, I am only asking abstract. I am not asking you to write the full objectives, methodology, nothing. Just one abstract. So abstract should have the objectives itself, few lines, the methodology, and finally the what are your results. And calculations you don't have to show here, and no explanation needed. So all calculations, basically idea is that you use these to convince yourself, and when you do these things by open-ended way, then that's the here lab pedagogy. Okay, because you are not doing physically in the lab, most of you except the 4 students, so at least you remain active. Okay, that's the idea. Any other doubt?
Sir,
We have
what
to
will
do
be
this for all the 4 gauges.
Sorry.
Sir, we have to do this for all the. I mean, we have to write the abstract for all the 4 types of strain gauges.
You don't have to write
Electrical,
4. You don't have to write 4 abstracts. You have to write only single abstract. You don't have to write 4 abstracts. You have to write everything in a single abstract, not more than 3/4 of a page. That's all.
Okay, sir.
Sir, what is this? What is the submission date for that? What will be the submission date?
Submission date is like you have done the last Thursday, so day after tomorrow is the submission date. Till
Sir, can you please slightly extend the submission date?
so how much you need extension?
Yes, sir.
Tomorrow is a holiday.
Of course.
Tomorrow is a holiday, and here I have reduced your work. You don't have to, write formal report, just abstract. Do calculations in rough. Don't have to type anything, equation, just you have to type text only. No diagrams needed. Abstract does not have any diagrams, nothing. So by Thursday midnight, is it not okay? Thursday midnight?
Sir, if possible, can you please increase the date?
How much you want increase? Will Friday be okay? Friday?
So till Saturday, can you submit?
Okay, for this week I'm extending to Saturday, but from next week it will be fixed 1 week, huh? Okay. Is that okay?
Okay, sir.
So this I'll set the deadline to Saturday.
Okay, sir. Thank you.
Thank you, sir.
Okay, let me also take you to
I
the.
will add some.
Please add. So Madhu, you can unshare now.
Friends here. Okay, my voice is audible.
Yes, audible.
Friends, so many type of instruments which are there in the lab, oscilloscope, accelerometer, multimeter, and then LCR. You should try to know about the principles and then its usage. That will also help you. You have to course. You should try to know the basics. I mean, what are these? What are the principles? How you have to use them? And then, of course, somebody you have to see that it's objective methodology results and then begin. That's all. Thank you.
Thank you, Dr. Dhawan. So now I am sharing the website of the course. So what I am doing is that as of now, the older versions of the lectures, they are uploaded. But now what I am doing is after every lecture, I am updating these. So lecture 2, lecture 3 up to lecture 3, the lectures are now visible. You click, and in fact for the last lecture I have given a very detailed write-up also, and there is now no password here. So this write-up is also there, and of course this at the end there will be the slides also. The slides which we covered, they are also here, so you can just go through this. So slides are also there and the write-up is also there. So up till lecture number 3 I have updated everything. Lecture 1, lecture 2, lecture 3, this is updated. Okay, so now if you want to see the format of the report, you will have to go to our course number 861. And anyone who has not done 861 but is doing this course, is there anyone who was not there in 861? Yeah, this is the website of the 861, and what you have to do is just go to useful links, and here the format for the lab report will be there. Okay, so format, you can use this format, but it's for the full report. But right now I have only asked you to write the abstract part. So if you open this, if you click this, the full format will come, but I have made your thing simplified. For the first experiment you only have to write abstract, nothing more than that. Okay, I think some hands are raised, so let me go from bottom. Limbasya, no, he has withdrawn the hand. Shakir's hand is still raised. Okay, so I assume,
I think that was on the query of 861 who haven't done that course.
Okay, fine. So those people who have not done CVL 861 course, so I hope that now you are accessible to the website, and those resources you will be able to see. Okay, fine.
Okay, sir.
So if you have any doubt, any confusion, so please let me know. Then only we will begin the what we are going today. So I assume that there are no further queries. So let me now share the presentation for today. But
Sir,
before that,
today's video will be available on. Sir, when will be today's video available on the portal?
okay, in the portal so far, lectures 1, 2 and 3, their videos are available. Okay, so today's lecture will be available most likely by tomorrow evening. By tomorrow evening it will be available. Okay, but the
sir.
slides will be
Yes, sir.
slides will be available. Two things are there. Slides I will make immediately available. Okay, slides I will make immediately available, and the video recording, because it takes some time for the conversion, I do little bit addition also. So for that give me say 24 hours, because what I am doing is I am doing desktop recording, and then to optimize that I do some editing so that the screen is larger in size for you. So for that give me little bit additional time. But lectures 1, 2, 3, their full recording is available, and also the slides are also available in the website. Alright, so I hope everyone can access the lectures, our channel. Let me just open the channel. Or everyone knows our channel, right? Okay, yes, Brijesh. Yes, what's your doubt, Brijesh?
Yes, sir. Format of the report is not accessible on the CVL 861.
Format is not accessible. What you are getting?
No.
Let me try.
Nothing. Actually, I am just clicking the link, but there is nothing to show.
Okay, just try this. The third link, sample lab report. Is that opening?
Yes.
Okay.
That is opening.
All right. So I will. Thanks for the updation. Maybe accidentally the Word file has been deleted, but don't worry. I'll make it available. Huh?
Okay. Thank
So,
you, sir.
but maybe you use the one below at least, and tonight I will update this also. Maybe accidentally some thing has happened.